Good morning, everybody. So, will you take your position correctly? Priyansi, I think it's better to come this side. More, yeah. So, everybody must have access to whiteboard. Why are you shaking your leg on study? Sit correctly. What the teacher is saying, what are we discussing, we have to know. What are the different methods of transmission of heat? Conduction, convection, and radiation. Conduction, there is no actual movement of molecules. In convection, there is actual movement of molecules. Hot molecules move from one place to another, and to fill that region, cold molecules come, right? And yesterday, Rakshak, he was talking about convection process. Here is convection process. Check here. Here is one experiment. So, hot air blows from one place to another and cold air enters. In ventilation system also same thing. In ventilation system, cold air enters from one direction and warm air goes from another direction, especially warm air goes from upper portion. In this room, there is no ventilation system, right? But if you notice in that window, can you see in that window? At the center, there is ventilation system at the top. Did you see it? In that window, right? And in that window also there is no ventilation. In ventilation system, there is small window just below the main window, right? Okay, and still some portion of um, presentation of our hero Rakshak was left. Now let's welcome Rakshak Rana Magar to present the remaining portion. Right? Okay.
That's all of it. And my dear Vice Chancellor and my dear friends, it's me Rakshak Rana Magar, and I'll be continuing the incomplete presentation that I did tomorrow, and today will completing it. My topic is radiation. Radiation is the transmission process of heat in which it passes from one place to another without any material medium. Convection and conduction uses radiation needs a material medium to transfer or pass heat. Heat radiation can pass through the vacuum or space as electromagnetic waves similar to light. Heat radiation can pass through through space as electromagnetic, just as light is similar as light. This makes radiation an efficient way to transform heat over a long distance. Some examples of radiation are the heat from sun and heat released from the filament of a bulb. This makes radiation an efficient way to transfer heat over a long distance. Some examples of heat are heat from the sun and heat released from the filament of a light bulb. So my next uses of radiation. Microwave ovens use radiation to cook food by passing microwave energy through the food. That is through. Okay. Yeah, you can. Yeah. As in convection ovens use hot air to use a fan to pass hot air to cook the food evenly, but in microwave ovens use radiation to cook food by passing the microwave energy through the food. Solar panels can cover sunlight to heat for use in houses. Solar panel can convert sunlight to heat for use in houses. Hold on. Houses and buildings. Radiation therapy is used to treat cancer by directing high energy radiation beams at cancerous cells to destroy them. The radiation therapy is used to treat cancer. Satellites use radiation sensors to collect data about the atmosphere of the Earth and climate. It is used to predict weather patterns and monitor environmental changes. Satellites use radiation to collect radiation sensor to collect data about the weather patterns to predict the weather patterns. Radios and television use electromagnetic waves to transmit information over long distances. Radios and television use electromagnetic waves to transfer information over a long distance. It is used in daily life. Oh, thank you, Abhishek.
Thank you. Thank you. So, actually, and this work was missing. This work was missing. That's why it was asked him to present today. So children are very smart in presenting. So radiation we can notice here. One minor example is given. Here is glowing bulb, right? And if we keep the hand of it down, we feel hotness, right? Here, heat is traveling without any medium also, right? And mainly this radiation is applicable to get energy from sun. From sun do you get energy or not? Sun produces energy by nuclear fusion. By which method? Nuclear fusion. Two types of energy are produced there. What are they? Heat energy and light energy. So we can get heat energy and light energy from the sun. And light does not need any medium. Without medium also it can come here, right? Because that is electromagnetic wave. And heat also comes in the same way, but that is radiation process. What is that? Radiation process. So radiation is a kind of transfer of heat from one place to another where there is no need of any medium. Without medium also it can travel, right? Microwaves, oven. Do you have microwave oven? So in microwave oven, food is cooked with the help of heat. There is also a radiation process. Without medium also it can be cooked. And so many examples you have already said, uses. Now the last portion is here. Structure and function of thermos flask. You can notice here. Thermos. Diagram you can just check it out here. A thermos flask. This is the cover. I think this is made up of plastic, and inside there is one vessel where we can keep the hot objects, right? Especially water can be kept, milk also can be kept. In some thermoses, food also can be kept, rice also can be kept, right? But there should be vacuum. One reason should be there. See here. This inner one is the vessel. This is the vessel, and vessel is here. This one is vessel. In vessel, we can keep liquid or food, whatever is there. But in between or outside of the vessel, here is one portion that doesn't contain anything. There is vacuum. There is gap. When there is gap, heat present in this liquid cannot come out. It cannot come out from here. Because it mainly needs either solid or liquid to travel. Radiation process is not applicable here. So if there is vacuum, it cannot escape from here. Then the food which is kept inside the thermos flask remains hot or cold. You can keep their ice also, yes or no? In some thermos, what can be kept? Ice. If you keep your ice remains in its position for a long time also. Because it doesn't melt. It doesn't gain any heat. So vacuum seal, outer case, and vacuum cork support, and double walled glass vessel and lid, and it is covered over here. I don't know. I think that water bottle is also similar to thermos. The water which is kept inside it remains hot for long or short? It doesn't, right? But the thermos which is used in your house mixes the food like that. If the hot food is kept there hot for a long time, minimum it stores for 24 hours. Up to 24 hours, temperature will remain same, and after some later on the temperature will either increase or decrease. Why did I say increase or decrease? If you have kept their ice, then temperature will increase. It will melt. And if you have kept their boiled water, then temperature will decrease. It won't be that much hot. So this thermos flask is very very essential for our daily use also. Generally, what do they do? The people who are working in office, they use thermos flasks for carrying their food or liquids, right? Okay, first portion of the chapter, energy in daily life, is over. Here are some MCQs. Now we are going to discuss. How much time is left? Still, we have got 10 minutes. Within 10 minutes, how much it is possible, we will discuss. Okay, ready? Are you ready? Okay, Group A, Group B, Group C. Question goes to Group A. Read the question, tell the correct answer.
What is the process of the flow of heat from a hot to a cold body called? Gradual transfer of heat.
Transmission of heat?
Yes, sir.
Are you sure?
Yes, sir.
So, Group B and Group C, do you agree? That's right. Okay, Group B. Number B.
Which one of the following is the degree or of hotness or coldness?
Temperature, are you sure? Temperature is the degree of hotness or coldness. Children, now you be habitual to make a circle, dark circle on it, okay? Dotted one. Now, Group C. By which method does the heat of the sun reach the earth?
Radiation.
Radiation. Okay, radiation, that's right. Number D. Number D. Group A.
What is the speed of incoming radiation?
Radiation is just like electromagnetic wave, like light travels 3 lakhs kilometer in 1 second. 3 lakhs kilometer in 1 second. So heat travels 3 lakhs kilometer in 1 second in radiation, right? Group B.
The C number. One number. Not
Oh, this is wrong.
yes, sir.
This is wrong. Means this 3 lakh. It becomes 30,000, right?
Yes, sir.
3 lakh kilometer means 3. 3. 3 here, 3 here. Okay. Next number, Group B. What is the process of transmission of heat in air called? Convection. That's right. This is also correct. Okay. So we have already completed it. Hello. Now, children, what to do? You have to prepare the note of radiation, draw the diagram of thermos flask, and mention the function of thermos flask. And MCQ, that is your classwork, homework, whatever you say, you do that one, right? And tomorrow we are going to discuss, not going to discuss, now I will give you work to the students, they will prepare the answer and bring, okay? And this exercise will be complete tomorrow. Question number 2, Kishore. Question number 2, differences between A, B, C, D. Kishore, mark it there. Nirajan, you are the commander. So write the name of the student and what is the question answer. Then tomorrow you have to report me. From Group A. Group B, Eunice. Question number 3, A, B, C, D, E, F. Mark it. Okay. Question number 4. Question number 4, it will be given to 2 students of Group C. Okay. Abhishek, A, B, C, D, and Priyanshi, E, F, G, H. Mark it. You just write down there. Oh. Now, question number 5. Question number 5. I will give it to two students. A, B, C, D. Nirajan. Okay, A, B, C, D, Nirajan. E, F, G, H, Karuna. Okay. Now, this diagrammatic question will be discussed tomorrow. We will discuss in the class. Understood? Whenever they bring all these questions and discuss, up to date. So remember, what is your duty? Do accordingly. All right. Now, be in action.